Problem 1, we need to determine the maximum effective horizontal reach of the bump for concrete pump. And the problem gives us the concrete floor at the ground level, and that also known as slab on grade, to be placed with the bump pump illustrated in figure below, as you can see there. And the 3-foot wide strip surrounding the concreting areas is needed for the slab side formwork. The question is, what is the maximum effective horizontal reach of the bump measured from the slab of the concrete, if the truck is positioned to scenario A, perpendicular to the floor edge, the bump is operated at the truck longitudinal axis. And the second scenario B, parallel to the floor edge, the bump is slew 90 degrees. So the first one, position is the trucks is positioned perpendicular to the floor edge. So let me put the just a symbolic finger here so you can see. Let us assume this is floor edge, this is a ground floor, and that is concrete we want to place, and the truck, the bump truck located perpendicular, and the bump length is here that we want to find out. And the strip wide is 3 feet, so it have to maintain the distance from the edge of the slab to the truck front is 3 feet that we have there. Then how we determine the effective horizontal reach of the bump? First, from the manuals, we can be able to find out what is the maximum horizontal reach of the truck in here, and that go to the chart. So here, as you can see, horizontal reach, because this one is on the ground level, then the horizontal reach, it will be this number, and this is the vertical reach, as you can see there. So we talk about the place concrete on the ground floor, so horizontal reach, and that from the manual of the chart of the trucks. So we have that is 98 feet 6 inches. And then we want to determine what is the distance from the slewing axis. This is slewing axis, as you can see in the truck, to the truck front. So because that will be a limit capacity there, limit. So this is what is the distance. What is the distance of that? So that we can be able to find out the maximum horizontal reach. And that one, as you can see, that is the difference between the two number, 35 feet 7 inches for the total length of the truck, minus from the slew to the back 26 feet 6 inch. That difference is equal to, you have to subtract that, and that 8 feet subtract 8 feet 10 inch. Where that number come from? I just show you there. It will be 35 feet 7 inches minus from the slew axis to the back 26 feet 6 inches. 6 inches. So that's where the number come from. And with that difference, we can subtract that to get the net horizontal reach, and that net horizontal reach is 6 inches minus 10 inches, so you get 1 here. So 12 plus 6 equal 18. 18 minus 10, so you will have 8 inches, and 98 minus 9, so it will be 89 feet 10 inches. And that is the net horizontal rate, 98 feet 8 inches. And we have a restricted strip, 3 inches for the formwork, for the temporary structure, scaffolding, 3 inch. We have to deduct that as well. So we have to deduct restricted strip 3 feet and 0 inches. Then from that one, we can be able to determine the maximum effective horizontal ridge from the slab edge. And that 8 minus 0, so it will be 8 inch. 89 minus 3, so we have 86 feet. And that is the answer for scenarios number 1, which is the truck's position perpendicular to the floor edge. Apply similarly for the truck position parallel to the floor edge. So if I show that how it goes, so here assume you have the slab that here, and the trucks, instead of perpendicular, do parallel, so that truck here, and we still have a outrigger that you have here to avoid overturning, and the bump, it will be from slew axis to here. And of course we still maintain the from the outrigger to the edge of slab is 3 feet, as you can see there. So from here, maximum horizontal ridge is still the same, 98 feet 6 inches for that scenario. So we have 98 feet 6 inches. And then the distance now from the slewing axis to the truck outriggers. So slewing axis to the truck outrigger. So that is the slewing axis to the truck outrigger. That is the question. And we see the width of the outrigger in both sides is 20 feet 5 inches. So you can divide by 2 to get that the question mark distance. So you get that is the distance from there to here is 10 feet 3 inches. Where that come from? It will be that one, 20 feet 5 inches divided by 2, and I round up. So that from 20 feet 5 inches divided by 2. That where it come from. And with that subtraction, we can get the net horizontal ridge from the truck's outrigger, and that it will be 6 minus 3 equal 3 inches. And then 98 minus 10, so we have 88 feet. So that's the net horizontal ridge. And then of course we subtract the restricted strip for scaffolding, etc., and that subtract 3, similar to scenario 1, 0 inches. Then we will get the net horizontal effective horizontal ridge from the slab edge. It subtract that, so you will have 85 feet 3 inches. And that is answer scenario. So compared to the first scenario, with the truck in position perpendicular to the floor edge, it's 86 feet 8 inches. With the position parallel to the floor edge with using the outriggers, the effective horizontal reach is 85 feet 3 inches. So a little bit shorter, as you can see. But the bottom line here, as you can see, compared to the boom length of this truck is 111 feet 6 inches. That is the maximum boom length we have. And the boom with the effective in this case only maximum is 86 feet 8 inches, which is compared to the maximum boom length, it is about 30% less. So this is illustrated why the nominal boom length should not be the sole basis for pump selection. We need to see how we configure the location of the truck, what is the restricted areas for temporary structure, etc. That will determine the effective boom length. So you cannot just get from the manufacturer chart to get that in the maximum boom length and that you can apply, but depends on the condition how you set up the method and what is the orientation of the trucks, the pump, so that the effective horizontal reach are not the same as you can see in this problem.